The first 10 million years in the history of Hawaii.
Table of Contents, Hawaii Part 1.
All about the first 10 million years in the history of Hawaii.
Dr. Sydney Soclof. Dr. Sydney22@gmail.com. 2023. Narration by Dr. Sydney Soclof.
Zoe Phonemes.
And Nathan Koltov. For a complete discussion of YouTube navigation, please go to tiny.1/YT Navigator.
The first 10 million years in the history of Hawaii.
Hawaii.
Hawaii was characterized by Mark Twain as the loveliest fleet of islands that lies anchored in any ocean. How did Hawaii get there?
Around 10 million years ago there were no Hawaiian islands, just an empty Pacific Ocean. Then a strange thing happened. Very deep within the earth is extremely hot molten material called magma. This liquid magma is under extremely high pressure and flows up the surface of the earth through cracks or weak spots in the earth's crust. Closer to the very center of the earth is a spherical core under such extremely high pressure that it remains solid. This is the inner core of the earth made of nickel and iron. The liquid magma is the outer core of the earth.
Further out is the mantle, a hot semi-liquid layer. On the Earth's surface is the thin solid crust, part of which is land, and most is covered by the oceans.
The average continental crust thickness is 22 miles thick. The maximum crust thickness is 56 miles underneath the Himalayas, and is 16 miles thick at its thinnest in various places.
The average oceanic crust is about 4 miles thick. For the entire Earth then, the average crust thickness is 9 miles.
To scale size, the Earth's crust would be about the thickness of 3 ordinary sheets of paper on a basketball.
If the Earth were the size of an egg, the Earth's crust would be 5 times thinner than a typical eggshell. The crust is only as thick as the eggshell at its maximum thickness underneath Nepal.
Hot plumes of molten magma spurt up through cracks in the Earth's crust and form volcanoes.
Here we see a plume of the molten magma spurting up through a crack in the Earth's crust to form a volcano.
These volcanoes occur on land, but even more often deep under the oceans, where they usually escape any notice at all.
This shows a plume of molten magma going up through a crack or weak spot in the mantle and crust of the Earth. When the magma reaches the surface, it is now called lava. The lava flow that results cools and solidifies on the ocean floor, forming a submarine mountain.
This shows the resulting submarine mountain after this volcano has become dormant.
In this case, the volcano rises above sea level, forming an island.
This shows the resulting island after this volcano has become dormant. The collapse of the magma chamber underneath the volcano often results in a crater.
A good example of a collapsed magma chamber underneath a volcano is the crater of Diamond Head on Oahu, one of the most famous landmarks of the Hawaiian Islands.
In some cases, the crater may drop below sea level, forming a lagoon.
There are many islands in Hawai'i, spread over a distance of several hundred miles. How did this come about?
Indeed, The Hawaiian archipelago extends some 1,518 miles, or 2,436 kilometers, from the big island of Hawaii to Kaua'i Island, just west of Midway Island.
We should distinguish between the island of Hawai'i, or Big Island, the state of Hawai'i, and the entire Hawaiian Islands or archipelago. The state of Hawaii is comprised of the 8 principal islands of the Hawaiian archipelago. The Hawaiian archipelago is continued by an underwater ridge, called the Emperor Ridge, that extends 6,000 miles across the Pacific Ocean, almost to the Aleutian Islands of Alaska. This is a line of extinct submarine volcanoes rising from the ocean bottom.
The answer to all of this has to do with tectonic plates.
The Earth's thin crust is floating on the semi-liquid mantle.
The Earth's crust is not continuous, but is broken into several pieces or plates. These pieces or plates of the Earth's crust are called tectonic plates.
This shows the Earth's core, the semi-liquid mantle, and the tectonic plates of the Earth's crust.
This shows the various tectonic plates of the Earth. They are in a wide variety of sizes and shapes.
The plates are moving slowly with respect to each other, typically just a few centimeters per year. Some plates are separating or diverging, such as those that meet in the middle of the Atlantic Ocean.
As shown here, where the North American and Eurasian plates are separating, as are the South American and African plates.
As the plates spread apart, molten magma wells up and becomes a lava flow. The result is a submarine mountain.
Since this also happens all along the length where the plates separate, the result is a submarine ridge.
As the ocean bed tectonic plates are pulling apart, molten volcanic material or magma in the form of lava flows up through the cracks and forms volcanoes. The lava spreads out and solidifies and forms an underwater ridge or mountain range.
In some places, the mountains reach above sea level and new islands are born.
The Mid-Atlantic Ridge. The outstanding feature of the floor of the Atlantic Ocean is the Mid-Atlantic Ridge.
The Mid-Atlantic Ridge is where the North American and Eurasian plates are pulling apart, as are the South American and African plates.
The Mid-Atlantic Ridge is an immense mountain range extending throughout the length of the Atlantic, claiming the center third of the ocean bed, and reaching 1,000 miles in width.
The Mid-Atlantic Ridge, though of tremendous proportions, is but the Atlantic part of the world encircling oceanic ridge. The Mid-Atlantic Ridge is like a submerged mountain range that extends through the middle of the Atlantic Ocean, almost from pole to pole.
The Mid-Atlantic Ridge is a submerged fault line that runs for some 10,000 miles from beneath the northern ice cap southwards,
and turns east around the southern tip of Africa to meet with the Indian Ocean Ridge.
Whereas the depths in the Atlantic Ocean are generally down to 20,000 feet, the Mid-Atlantic Ridge has a depth usually less than 5,000 feet, and in some places reaches close to just a few hundred feet below the surface.
Some volcanic islands that rise above sea level from the Mid-Atlantic Ridge are Iceland, the Azores, Ascension, St. Helena, Tristan da Cunha, Gough, and Bouvet. Toward the northern end of the Mid-Atlantic Ridge is Iceland, the largest land made from oceanic crust. Iceland rises from the crest of the Mid-Atlantic Ridge, which passes straight under the island. It is one of the newest lands on the Earth. This shows the Mid-Atlantic Ridge in Iceland.
The Mid-Atlantic Ridge passes right through the middle of Iceland.
There are several active volcanoes in the region where the Mid-Atlantic Ridge passes through Iceland.
Indeed. There are some 200 volcanoes in Iceland.
Iceland is still being formed. The volcanic island of Surtsey off the southern coast was formed by eruptions that began in 1963.
Here is another Icelandic postage stamp commemorating the formation of the island of Surtsey, which began with a volcanic eruption in 1963. In addition to volcanoes, there is much geothermal activity, including numerous geysers. Here is an amazing picture. The ridge manifests itself very strikingly at Þingvellir, Iceland. Along this road, you can see the Mid-Atlantic Ridge pulling the island apart. Eventually, Iceland may become two separate islands.
On the right side are the rocks headed for Europe, and on the left to North America.
The gap increases at a rate of about 6 feet, or 2 meters. Hey yeah.
Þingvellir is only a few miles from Reykjavik, the capital and largest city of Iceland.
Hawaii. From 10 million years ago to today. All around the Pacific Ocean where the big Pacific Plate meets surrounding plates. There is an area of strong earthquake and volcanic activity called the Ring of Fee. This arc around the Pacific Rim is called the Ring of Fee because of the concentration of volcanic and seismic activity.
The major trenches on the map are located where tectonic plates meet, with one being driven under another.
The Aleutian Island chain, or archipelago, was formed by a series of volcanoes erupting at the boundary of the Pacific Plate and the North American Plate.
In the Maui 48 states, this chain of volcanoes is continued by Mount Rainier and Mount St. Helens in Washington, Mount Hood in Oregon, and Mount Shasta and Mount Lassen in California.
The Pacific Plate is being forced underneath the North American Plate in a process known as subduction. This produces cracks in the Earth's crust.
The process of mountain building can be the result of one plate sliding underneath another plate, called subduction. This produces cracks in the Earth's crust.
The resulting heat and pressure cause the rocks to melt, forming molten magma. This then percolates upward through the cracks to become lava flows and volcanoes. This is where the Pacific Plate and the North American Plate meet all along the west coast of the US and Canada. The Pacific Plate is moving in a northwest direction underneath the North American Plate at a rate of about 2 inches or 5 centimeters per year.
Now how about Hawaii? Hawaii is not in the boundary between tectonic plates. In fact, it is right in the middle of the Pacific Plate.
The Hawaiian Islands are actually in the middle of the Pacific Plate, but they are volcanic in origin. How does this come about? Also, the islands are of vastly different ages. The Big Island of Hawaii is by far the youngest and still growing, with active volcanoes adding land to that island. If these islands were due to a crack in the plate, shouldn't they all be about the same age? However, they are very much different in age. The Big Island of Hawaii is still growing. Maui is about 1.1 million years old. Molokai is 1.8 million years old. Oahu is 2.5 million years. And Kaua'i is very old, at 4.7 million years. Going beyond Kaua'i to islands further distant, we see that there is a definite relationship between distance and age.
In fact, we see a ridge and a chain of small islands extending a very long distance northwest from Hawaii, past Midway Island, and then almost all of the way to Siberia.
The Emperor Ridge has even older islands than the Hawaiian Islands.
hail are the ages of the islands and underwater mountains in the Hawaiian and Emperor Ridge chains.
The islands of the state of Hawaii are the youngest part of this entire chain.
So, how did all of this happen? It is because of the Hawaiian hotspot. But no, I am not talking about Waikiki.
Let us look at the hotspot theory to explain this.
A pocket, or reservoir of the magma forms in the mantle.
This pocket of magma in the mantle is called a hotspot.
When there is a crack, or weak spot in the crust above the mantle, the molten magma can force its way out.
And the eruption of lava can produce either a submarine mountain, called a seamount, or
an island. Here is lava flow from Kilauea on the big island of Hawai'i, adding new land to the island.
Here is an overview view of the lava flow from Kilauea.
This is lava flow from Kilauea on Hawaii.
This is another view of lava flow from Kilauea on Hawaii. The Pacific Ocean plate is part of the Earth's crust, which is drifting very slowly to the northeast. As the crust moves, the weak spot in the crust moves along with it. This cuts off the flow of magma up from the hot spot. No longer being supplied with fresh lava, the island stops growing. Indeed, due to subsidence and erosion, the island will gradually shrink in size.
The island might even sink under the sea and disappear from view.
As the crust moves, other weak spots move along with it. Eventually, another one may come into position over the hot spot.
And the process of island formation can begin again. The result is a chain of islands being formed, as shown here.
And in this case, the Hawaiian Islands.
It is only the youngest island, the big island of Hawaii, that still has active volcanoes in the southeastern part.
The older islands to the northwest are aging and getting smaller by erosion, and sinking back down into the oceanic crust.
The youngest island, the big island of Hawaii, is the big baby of the Hawaiian Islands,
and is still growing.
Kaua'i is the old man of the Majo Islands,
and is shrinking and getting wrinkled by erosion.
A good example of this erosion on Kaua'i is Waimea Canyon, and also the Napali coast. At the other extreme, the youngest island, the big island of Hawaii, has a relatively smooth surface. This process has continued for millions of years.
And fail islands and submerged islands, or seamounts that extend thousands of miles beyond Hawaii.
Here is another illustration of the same process.
The Pacific Ocean is very deep, so the Hawaiian Islands are very high with respect to the sea flow. In fact, Mauna Loa and the Big Island of Hawaii is considered to be the most massive mountain on Earth.
Mauna Loa is a shield volcano on the Big Island of Hawaii. It is the largest single mountain in the world, rising over 30,000 feet above the ocean floor, and reaching almost 100 miles across at its base.
When Mauna Loa is measured from its base, which is the sea flow, 16,000 feet, 5,000 meters below the ocean surface, to its highest point at 13,800 feet, 4,170 meters above sea level.
The total height is some 29,800 feet, 9,170 meters, as compared to Mount Everest, which is 29,035 feet, 8,850 meters.
This is what the island of Hawaii would look like if the surrounding ocean were to be removed.
Mauna Loa is even taller than Mount Everest when measured from its base on the Soclof.
The volcanoes in the Hawaiian Islands are generally shield volcanoes. Shield volcanoes have low slopes and consist almost entirely of frozen lavas.
Shield volcanoes almost always have large craters at their summits. The name comes from a resemblance to the shape of a warrior's shield.
The island of Hawaii is built from 5 separate shield volcanoes that erupted somewhat sequentially, one overlapping the other.
These are, from oldest to youngest, Kaua'i extinct, Mauna Kea dormant, Ha'alele dormant, Mauna Loa active, and partly within Hawaii Volcanoes National Park, and Kilauea very active, and part of Hawaii Volcanoes National Park.
This is a satellite view of the island of Hawaii.
There are other hotspots in the world besides the one below Hawaii. Here are some of the prominent hotspots in the world.
Hotspots can also occur below the land surface, as is the case of Yellowstone National Park.
Note Iceland and the Azores in the Atlantic Ocean are not over hotspots, but at plate boundaries.
Kaua'i.
Kaua'i is almost 5 million years old, so a lot of erosion has occurred. Evidence of that is the spectacular Waimea Canyon.
Mark Twain was entranced by the Waimea Canyon and called it the Grand Canyon of the Pacific.
A road leads up to the Waimea Canyon lookout at an elevation of 3,400 feet.
This is the Waimea Canyon.
This is a view of the Waimea Canyon.
This is another view of the Waimea Canyon. This is the Waimea Canyon. This is another view of the Waimea Canyon. Maui.
Maui is 1 million years older than the Big Island of Hawaii, so a considerable amount of erosion has occurred there as well.
A good example of that erosion is the Iao Needle in Iowa State Park on Maui.
This is the location of Iowa State Park on Maui.
This is the Iao Needle in Iowa State Park on Maui.
This is another view of the Iao Needle. Kukumoku is an erosional remnant. It is at the end of a ridge comprised of a denser dike stone. The softer rock around the dike stone was eroded by streams and waterfalls.
Stage 1, Eruption. A shield volcano forms the foundation of the West Maui Mountains. For 1 million years, molten rock magma fountains into the eye and runs down the sides of the growing volcano.
Stage 2, Caldera. The loss of magma from the summit results in a collapse that forms a caldera. Erosion begins with the formation of gullies on the flanks of the volcano. Stage 3, Erosion. Hot, steamy gases continue to rise and soften the rock long after the lava flow ceases. Rain collects near the former summit, and the Iao stream gradually cuts through the softened rock.
Stage 4, Valley. As erosion continues, an amphitheater valley is sculpted. Small extremes erode side gulches and enlarge the valley. The deposited rock and soil at the mouth of the valley add to the Wailuku Plain.
Stage 5, Stabilization. As plants carpet the surface, they stabilize the valley walls and floor. But what began as a native Hawaiian forest has become a landscape dominated by alien vegetation.
Recommended videos. The first 10 million years in the history of Hawaii. Recommended video. History summarized. Hawaii.
Recommended video. Quick history of Hawai'i. That was history.
Recommended video. Volcanic origins of Hawaii. How the Earth was made. Series 1. Episode 12.
Hawaii history. Timeline. 5 minutes. 51 seconds.
Table of Contents. Hawaii Part 1.
Thanks for watching. Please watch some more of my great videos.